Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Aribhat College, University of Delhi. So in this series of our lectures, which is dedicated to Introduction to Programming using C++, this is presently our third lecture with the topic of inheritance. And in the previous lectures what we have seen is what actually inheritance is, and among the five types of inheritance, we have seen the four types, which were single inheritance, multiple inheritance, multi-level inheritance, and hierarchical inheritance. And today's topic is hybrid inheritance. So as the name suggests, hybrid. So hybrid is basically nothing but a combination of more than two or more than two. So here also the same thing goes on. Hybrid inheritance is actually the combination of two or over two types of inheritance. For example, let's say we have a program in which classes are arranged such that there are kind of two types of inheritance. One could be single inheritance or multiple inheritance, and at the same time hierarchical inheritance is also taking place. Such an arrangement is known as hybrid inheritance, which is basically a combination of two types of inheritance. And now, as I have told you that two types of inheritance are being combined in case of hybrid inheritance, we can say that this is the most complex inheritance among all the types of inheritance available in case of C++. And the usual rule which goes along is data members of the base class will be accessed according to the specified visibility mode. Whatever visibility mode we will be specifying while inheriting the class, and whatever accessibility mode the members are having in their original classes, these two things will decide the fate of the data members when inherited inside the derived classes. This is a usual rule. So for example, we have visibility mode in the base class as private, public and protected. So private, as you all are aware, that we will not be able to inherit, and public and protected can be inherited, but how they will behave in the derived class, that actually depends on the visibility mode which is being specified in while performing the activity of inheritance. So this is a usual rule which we have already kind of studied in our previous lectures of inheritance. Now coming to the hybrid inheritance again. So let's say we have a situation that we have three classes A, B and C, and these three classes are basically kind of being inherited by a class D, while this class D is again being inherited by class E and class F. Now let us try to understand that what all models or what all types of inheritance are being taking place here. So if you can see the only above two levels, which is class A, B, C and class D. So class D, which is a single derived class, is inheriting three different base classes, which are class A, class B and class C. So this is a kind of, we can say, multiple inheritance. So single inheritance is there when the single base class is being inherited by the single derived class. Here the classes are multiple, so multiple inheritance is there. And now if we can see the situation that class C is being inherited by class D, and class D in turn is being inherited by class F. So now what is this giving us an impression of? So class C being inherited by D, and D in turn is being inherited by class F. So this is actually a multi-level inheritance, you can say. So here this figure is actually a combination of two types of inheritance. One is multiple inheritance, another one is multi-level inheritance. So this type of situation is basically known as hybrid inheritance. Now how this hybrid inheritance takes place, let's see. So here the example which I have shown is a combination of multiple and multi-level inheritance, but we can have other examples also in which we have single inheritance and then other inheritance combined with it. Now taking the syntactical example of the scenario which was depicted in the figure, class A, B, C, which being taken by class D in turn taken by E and F. So let's say we have a class A, then we have a class B along with their own standard definitions. Now here we have another class which is class C, which is in turn inheriting class A and class B both with their specific visibility modes. Now with their specific visibility modes means, so class C when inheriting class A may say public, private or protected, and similarly for the class B as well, while inheriting the class B, class C can inherit the class B in either public, private, protected mode, and it is having its own definition. So this is basically, we can say kind of one level of inheritance which we have shown through syntax here, in which A and B are being inherited by class C. Now class C again is being inherited by class D, taking its specific visibility mode, which is shown by class D, visibility mode public, private or protected, and class C. So this basically says that class C is being inherited by class D with a specific visibility mode. And another, we have class E also, that class E is also inheriting class C. So now the figure which you can imagine is class A and B at the top level, both being inherited by class C at the second level, and at the third level we have class D and class E, which are inheriting the class C. So basically the derived class C inherits two base class A and class B. So clearly a structure which we can say multiple inheritance. Now further, two subclasses D and E are inheriting class C. So this is the structure of hierarchical inheritance. So the overall structure of hybrid inheritance here is including more than one type of inheritance. So till this point we have just seen that what actually hybrid inheritance is and how it is going to takes place syntactically. So now what happens when we have a situation of inheritance which is having a combination of two types of inheritance and results in hybrid inheritance? Let's see this with the help of a complete programmatical example. So in order to see the working example, we are going to see a particular program, and with a standard IO stream and namespace standard, let's define the first base class, which is class electronic device. And this class electronic device is having one constructor, and as I am saying it is having one constructor, it is kind of very very clear that this constructor is going to sit into the public section, and here we have the electronic device as its constructor, and this electronic device constructor is actually doing nothing but printing one statement that I am an electronic device. Now this is the first base class. Now coming to the another base class, we have one class computer. This class computer is also in its relevant class definition. This class is also having one standard constructor, obviously under the public section, and this is printing on the screen, I am a computer. Now we have two base classes. One class is electronic device and another class is computer, and both these two classes will serve as the base classes. And now for corresponding to these base classes of electronic device and computer, let's have one derived class. So we have one derived class which is named as Linux based, and it is inheriting the two base classes already defined, which are electronic device and computer. Now coming to the visibility mode, this derived class Linux based is inheriting electronic device into using the visibility mode public, and also it is inheriting the base class computer using the visibility mode public. And here, for the sake of simplicity, we have not given any specific class definition for Linux based. This is just we have given one empty class definition for Linux based. Now this was one derived class with two base classes. Now let's have one more derived class which is not deriving electronic device or class computer. In turn, it is deriving the class Linux based. So now imagine a scenario where on the first level you have two classes, one is electronic device, another one is computer, that is being inherited by one class Linux based, and now this Linux based in turn is inherited by class Debian in public mode. And again, for the sake of simplicity, we have not given any definition of this class Debian. It is not doing anything, and we have left the class definition part as empty, which is shown by opening parenthesis, closing parenthesis, followed by a semicolon, which in turn we can say show the end of the class. Now what are we going to do inside the main function? We have to create an object of the derived class. Now which derived class we are talking about? Here we have two base classes which is electronic device and computer. Both are being inherited by the class Linux based, and Linux based is inherited by class Debian. So here Linux based is also a derived class and Debian is also a derived class, but here we are going to kind of make the object or create the object of Debian class. So we have created Debian obj, which is an object of Debian class. Now what will happen whenever we create the objects? The constructors are being automatically called. Now here, if we can see the previous screen, inside Debian we don't have any class definition. Again, inside Linux based also we don't have any class definition. So what will happen here? In the class Debian, whenever an object is being created, it will see that there is a kind of class which is being inherited here, which is Linux based. It will go to the constructor of the Linux base. We don't have any explicit constructor of the Linux base here, no problem. Then Linux base, going to the definition of Linux base, this compiler will encounter that there is an electronic device and there is a class computer which are being inherited, and thus in turn the compiler will go to the base classes which are electronic device and computer, and will implement or execute the constructors given inside electronic device and the computer class. And as an output, what are we expecting is whenever the object of Debian is being created, as Linux base is not having any constructor, but Linux base is inheriting electronic device and computer. They both are having constructors, so these two constructors should kind of we can say be executed or be called. And here is an kind of we can say output screen which shows that I am an electronic device, which is the statement from the constructor of electronic device class. And again the next statement is I am a computer, and this is actually a statement from the constructor of the computer class. So this whole phenomena basically indicates that Debian has called Linux base in turn has called electronic device and computer respectively, because electronic device is mentioned at the first place when we are inheriting these two in the Linux base. So electronic device is mentioned first, followed by computer. So this will be the sequence of statements of the constructor, first the statement from electronic device and next the statement from computer. So this hierarchy, we can say this inheritance is actually combining two types of inheritance within these three classes, electronic device, computer and Linux base. So electronic device and computers, two classes being inherited by a single base class which is Linux based. So they form the structure of multiple inheritance. And if we see the next level, which is Debian and Linux base, so Debian inherits the class Linux base, forming the structure of single inheritance. So this single inheritance and multiple inheritance combined with each other is giving you the flavor of hybrid inheritance. So what actually is happening is when an object of derived class Debian is being created, this is what we have done in our program, the constructor of all its superclasses are called. But Debian, the constructor of Linux base, which is the immediate base class of Debian, is missing in the definition. So here we are not getting any reflection of that. But Linux base again is calling constructor of electronic device and computer, and hence we have got the output which we were expecting. So till this point we have completed all the types of inheritance which are actually your single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance and hybrid inheritance. All the five types of forms of inheritance, all the five types of inheritance we have seen. Now let us try to explore some kind of more common problems or more common fundamentals of inheritance. So in order to explore other things within the concept of, within the topic of inheritance, we have encountered one problem which is named as diamond problem. So diamond problem occurs in inheritance when there is a scenario such that there is a derived class inheriting the attributes of two base classes or two superclasses, and these superclasses have a common base class. So let's try to see, or let's try to understand the concept of this diamond problem using a particular figure. So we have one base class which is the base class for two classes, class 1 and class 2. So class 1 and class 2 are inheriting base class, and then the derived class is again inheriting both the classes, which is class 1 and class 2. So the two classes, class 1 and class 2, inherits the same base class. Now what is happening? What is the problem which we are naming as diamond problem? So in class 1 and in class 2 there are two copies of the base class. One copy of the base class taken by class 1, another copy of the base class taken by class 2. Taken in the sense I am talking about inherited. And now when we are talking about the derived class, it is inheriting class 1 as well as it is inheriting class 2. So apart from the data members of class 1 and class 2, the derived class will be having 2 copies of data members of the base class. One copy of the data member of the base class comes from class 1. Another copy of the data members of the base class comes through class 2, and hence it is going to create a problem that whenever you are going to access any such member which is of the base class and its 2 copies are being created inside the derived class, if you are not going to tackle it properly, your compiler is going to get confused and ask that which copy of the data member I am talking about, one which is created through class 1 or the another which is created through class 2. So this type of scenario, this type of error is actually known as the diamond problem, just because of the structure it is forming. It is forming as a structure. It is forming a structure of diamond. So when the object of derived class access a member of the base class, it is going to cause an ambiguity, and this ambiguity is caused just because your system is unclear that which copy of the base class member it needs to be accessed, and in such a situation compiler throws an error. Now in many of the materials over the internet or in the books, you will find this problem definitely whenever we are talking about the topic of inheritance, but it may or may not come under the name of diamond problem. But in order to understand the structure, it is easier to name it as the diamond problem. Now we have understood what is the situation and what is causing the error and why it is causing the error, just because it is having 2 copies of the same member. Now how it is happening, let's see it programmatically. So we have one base class, and within that base class we have one member in its public section which is integer x. Now see what is happening. Whenever we talk about the class 1, it is inheriting base class in public mode. It is having one of its own member y. Similarly, we have a class 2 which is inheriting the base class in public mode, public visibility mode, and it is having its own z, one public member which is z. Now after inheritance, this class 1 and class 2 will be having one copy of the member x within them and their own members y and z respectively. So class 1 is having x and y and class 2 is having x and z. Now coming to the next situation, which is derived class. The next derived class, we have a derived class which is taking class 1 in the public mode as well as class 2 in the public mode, and it is having one of its own members which is sum. Now imagine the situation of derived class, that this derived class is having x, y and the another copy of x and z, and also the member sum which is its own member. Now within the main, inside the main function, let's say I am creating an object of the derived class, let's say obj, and as all the members being public, I am asking obj dot y equals to 20, fine. Obj dot z equals to 30, that is also fine. But whenever I am saying obj dot x equals to 10, that is going to give me an ambiguity. So if I am going to say sum is the sum of x, y and z written with proper syntax, obviously this is not going to give me the answer. Instead I will be facing errors as obj dot x equals to 10 is ambiguous because there are 2 copies of x, so the compiler will clearly show that x is ambiguous, and within the statement obj.sum is equals to obj.x plus obj.y plus obj.z, it is again going to raise that similar error that x is ambiguous, and this kind of problem is actually known as the diamond problem. So in this lecture what we have seen, two things. One is the last type of the inheritance, which is the hybrid inheritance, and another one is the diamond problem, which is a very common problem when we talk about inheritance. And here is a list of references which are being used in preparation of this lecture. Hope you have enjoyed the lecture. Thank you.